Okay, so now on the second one, we're going to do the same first step in that we're going to combine these two logs, except now it's minus, right? It's a negative between these two. So since we're subtracting, instead of multiplying the two a values, we're going to divide them. Okay, so we're going to do log base 7 of 8x squared divided by 4. And then we just bring this side down. Didn't do anything here. Now again, notice I've got logs on both sides. Here I did not. Here I do. So here I can just cancel those out. Now as I'm going to bring these down, as I do that, I'm going to go ahead and simplify this part. So I can divide this 8 by the 4, which is 2x squared. And then I bring the 50 down. And now what I want to do is I want to get that x squared by itself. So let's divide both sides by 2. Okay, and now we have x squared equals 25. And then you guys might recognize it now. If I have x squared, I want to square root both sides. And x equals 5. But don't forget that x also equals negative 5, because there are two solutions whenever you square root x squared. Okay, next one. Here we're simply just simplifying, but we got to remember here that I've got a negative, right? It's almost like a negative 1. So if I have a negative 1 right there, I'm actually going to want to distribute that negative 1 to both of those terms. So I'm going to rewrite this as 5 minus I. And remember, these are imaginary number i's. Okay, so minus 3, then negative 1 times 2i is minus 2i. Now you just combine like terms. So 5 minus 3, 2. And then negative I minus 2i is negative 3i. Okay. Now this one, it's the same numbers, but there's no number between, so that means we're going to multiply, which means we need to set up the box. Okay, so these numbers go on the outside, 5 and negative I, and then right here we have 3 and positive 2i. Okay, so now I'm going to multiply all the way through here. So 5 times 3, 3 times negative I is negative 3i, 5 times 2i is positive 10i, and then here this is, remember this is like a negative 1, right? So negative 1 times 2, that's negative 2, and then I times I is I squared. Now here's what's important with I squared, is that we need to remember that I squared is equal to negative 1. So this ends up being negative 1 times negative 2, which is positive 2. Okay, so I'm going to basically change that number into positive 2. Now, these two are like terms. So 10i minus 3i, well, that's 7i. But these two are also like terms now because of that I squared turned that into a positive integer. So now 15 plus 2 is 17. Remember, you always put the real number first. Notice how we have the number without I here, the real, and the 17 goes first. Okay? Now the last ones are factoring. Okay, so factoring here, what I'm going to do with two numbers is do a 1 by 2 box. And then every time we factor now, you put the numbers inside of the box. If I'm just simplifying, multiplying, they go outside. If I factor, they go inside. Okay, so here, 6x cubed. Now I will look for the common factor between these two terms. First I look at the 2 and say, okay, well, 2 divides into both of those. And remember, the biggest common factor, not just the smallest. And both of them have at least 2x variables. So 2x squared is the common factor. So now I need to figure out what are the factors up here. Well, 2x squared times what gives me 2x squared? Well, that's 1. 2x squared times 3x gives me 6x cubed. So there's my other factors. So now I write this out as 2x squared times 1 plus 3x. I don't need to do anything else. I'm not solving for x. I'm not setting this equal to 0 and solving for x. That's literally all you're doing when you're being asked to factor. Okay, now 3 terms, starting with the squared and x and a just constant. We're going to set up x in the box, a 2 by 2 box. So remember, you multiplied the first and the last, so you get 6x squared here. You write down the middle down here. Look for the two numbers that multiply to 6 and then add up to 7. In this case would be 6x and 1x, because 6 times 1 is 6. 6 plus 1 is 7. Now in the box, we put the first term. In the last box, we put the last term. Then we take these two numbers and we set them up here in the empty spots. Now we kind of do the same thing we did over here. We look for factors on the outside. Now I already know that the greatest common factor for 2x squared and 6x right here would be 2x. And then I say, okay, 2x times what equals 2x squared? That'd be x. 2x times what gives me 6x? 3. X times what gives me 1x? 1. And does 1 times 3 equal 3? Yes, so we know we did it right. All right, so now I'm going to write these out. 2x plus 1, that's from this side. And then x plus 3 from everything on top. And I could write this first. I could put x plus 3 here and then 2x plus 1. It doesn't matter what order you use, okay? So again, that's all you need to do. You don't need to solve that or write x equals negative 3 or anything like that. You just leave it like that, okay? Okay, last couple here. Now remember, these are perfect squares. So anytime you have a minus in the middle and two perfect squares, and the perfect square here, by the way, is a 1 and the 9, I can go straight to this without doing the box. And basically I take the square root of that and the square root of that. The square root of the first one is just x. The square root of the second one is 3. So that's the second term. And then we put plus and minus. And again, I can put minus here, plus here, it doesn't matter. And again, all I was doing was factoring those out. Okay, last one here. Okay, so now factoring by grouping. Okay, so factoring by grouping, what we do, remember we split it in half. First, we look for the common factor between these two terms. Okay, so first that would be 5. I can divide 5 into both. And they both have at least 2 a's, so a squared. All right, so now, kind of like we did here in that 2 by 2, or that 1 by 2, we got to look for what would I multiply times 5a squared to get 15a cubed. I'd have to multiply 3 times a. So this times this should equal this. Same thing here, 5a squared times what gives me 10a squared? Well, that'd be just 2. So plus 2. Now what you do is you bring this factor over to this side, and you repeat the same thing. But now I kind of go backwards, and now I'm looking for the common factor last. So what would I multiply here times 3a to get 6a? That'd be 2. All right, so now what I do is I take those common factors that I got there, the 5a and the 2, 5a squared.
Attention students, will Musta Amiri please come to the front office? Will Musta Amiri please come to the front office? Thank you.
Plus 2. And then I take the other factor, 3a plus 2. And then there is that problem factored out.